All right. So up to this point, we have talked about angle measures inside a circle or on the circle. So we have our circle with our central angles at the center. Okay, so remember this equals this. So this is 45, this is 45. And then we talked about our circles where the angle is on the circle. Remember, so if this is, to say, 60, this is 30. Okay, so we're going to talk about two more different kinds today. We're first to talk about angles inside the circle by secants. So again, secants are like chords, but it goes through. So it intersects the circle at 2 points, and it keeps going. They're lines. They keep going. Okay, so that's what secants. Now, this theorem, what it's saying is, when it's not at the center, so when the center is right here, the center right here is roughly about right there. Okay, when your angle is not at the center, what we do is we look at the two arcs that intersected. So we have a major arc and a minor arc. Major arc being the bigger one, minor arc being the smaller one. Not necessarily over 180 or under 180. We just use major and minor in this case now to represent the bigger one and the smaller one. We add those two values. We add this plus this, so this arc plus this arc, and then divided by 2 will always give us the angle here. So the measurement of angle 1 right here is major arc minus minor arc. Now, it has to be across from the angles. Remember, these are vertical angles, so these two angles are the same already. So these are the arcs of that angle right there. We're not dealing with this arc or this arc. Okay, so be mindful which arc to use. So for example here, we're looking for the value of x right here. All right, let's look at the two arcs. We have our major arc. So if you're not sure which one, just follow these legs. It goes from here around all the way to the next intersection right there. So this is our major arc. This is our minor arc. Follow the leg here all the way around here. So we're going to do angle x equals major arc 100 plus minor arc divided by 2. Well, 100 plus 50 is 150. So the measurement of angle x equals 150 divided by 2, which gives us 75 degrees. It's a 75 degrees right there. All right. So what about if we have the interior angle, but we don't have this? Well, we still use the same formula. Remember, is the measurement of the angle is equal to major arc plus the minor arc, all divided by 2. Okay, well, the measurement of the angle is 90, so we have the degree, 90 degrees, that's equal, and we have the major arc. And we're assuming in this case just because it's pretty obvious as this is the bigger one, so we're going to call that the major arc. So 140 plus the minor arc, that's what we don't have, all over 2. So now that we have this set up, how are we going to solve this? Again, the idea now is to get x by itself. So to do so, we got to get rid of this 2. So we multiply both sides by 2. Cancels this out right here. And 2 times 90 is 180. That equals 140 plus x. You then subtract the value of x. You get 40 equals x. We'll double check that. 140 plus 40 is 180 divided by 2, 90. Yep, that worked. You did it right. Good job, y'all. All right. Now, anytime, and this kind of works similar to the very first one we talked about here, where the angle is on the circle. It's still the same idea. It's just it happens that one of the legs stick out. So when your angle is on the circle and is formed by a chord or a secant of some sort and a tangent, and they meet at the point of tangency. So this is a tangent line. Tangent line. This right here. Point of tangency. Tangency. Okay. This is it could be going through the center, could not sure. But what this is saying is anytime some chord, secant, anything intersects a tangent line at the point of tangency, this angle right here is half of the arc that's in there. So the arc of this angle goes from this point right here all the way around until the point of tangency. So it goes all the way to the actual angle itself right there. So in this case, since this is 180, the value of this angle then is half of that, 90. Let's practice that a little more. So here, we're looking for angle X and angle Y. So let's start with this. So this is 40 right here. This is an angle on the circle. So let's find its arc. So that's on the circle right there. The arc goes across from here all the way to here. That means that the arc itself is double that, 80. That's 150. So to find X, we got to find its arc. So let's change the color. To find X, we'll start with X first. So angle X, the arc of angle X goes from here all the way to right there. So this circle is divided into 3 arcs. This blue arc is 150, and now this 80 right here. So we have 2 of the 3, so we're going to add them up. So 150 plus 80, that'll give 8, 9, 10, 11, 12, 13, 210. And now all 3 of them make 360, so 360 minus 230. I say 210, 230. 0, 3, 1, 130. Again, this is an angle on the circle, so if this is 130, it'll be half of that. It'll be 65. All right, going back to this over here, we'll go with red. So Y right here is just like we talked about. So the arc of this goes from here all the way to the point of tangency, which happens to be the same as the green one right here. So that makes Y equal 40. Because again, it's half of the arc it intersects. This is the intersecting arc. Happens to be the same as this 41 over here. All right. Now this last one, it's broken up into 3 parts, but they're all done very much the same. All right. A lot of words here, but we're talking about angles outside the circle. So we talked about angles, central angles, angles on the circle, and angles in a circle. Angles that are formed inside the circle that are not the center. Now we're talking about angles that happen when the intersection outside. So angles outside the circle, these outside angles right here. Now these can be formed in 3 different ways: 2 secant lines or chords, a tangent and a secant, or 2 tangents. The idea is still the same. All these. I'm going to do the major arc in red and the minor arc in blue, just so you can see. Where the arcs are at, though, is different. So the major arc of this one right here, again, is between the 2 points right here, from here to here. The minor arc is closest to the angle itself, still in between the 2 legs of the angle. Major arc goes from the point of tangency to the next intersection, so this. Minor arc goes from that point of tangency towards the angle, still bound in between the 2 legs. And then on 2 tangent lines, it goes from point of tangency to point of tangency. They're there. And then the minor arc, same thing, point of tangency, but on the inside. Ran out of ink right there. Alright, and we're going to do major minus minor divided by 2. Similar to the last one, where you do the big one, but last one we did major plus minor. We're doing major minus minor divided by 2. Major minus the minor divided by 2. Major minus the minor divided by 2. Let's practice this. Since we practice it. Alright, so here we got 2 tangent lines. So we got our minor arc. We don't know what that is. Call that X for now. And our major arc. Now, the great thing about 2 tangent lines is that it breaks your entire circle into 2 arcs. Yeah, you have the big half and the smaller half. So if this is 210, to get X right here, you take 360 minus that 210. Do so, you get 150. That means this is 150 over here. So now, to do this problem, we will do the measurement of angle Y equals the major arc, 210, minus the minor arc, divided by 2. So 210 minus 150 is 60 divided by 2 gives me 30. So y here is 30 degrees. All right, let's try this one over here. This is broken into 3 arcs. This arc, and this arc right here. We're still looking for the outside value of the angle. So we're still doing a measurement of angle X is equal to the major minus the minor divided by 2. Major minus minor divided by 2. Now, this is very nice. They gave us this value right here. The reason being, this arc right here, and of course this inside angle arc, all added to 360. So we have 2 to the 3. So we add those two up, we get 160 plus 120, that gives us 280. And then we subtract that from 360, what do we get? 80? Yeah, 80. Making this arc right here 80. So now we got to then figure out, hey, which ones are major, which ones are minor. Major, again, is goes from the point of tangency to the intersect the point of the next leg. So this is 160. And then our minor goes from that point of tangency inwards to a circle to the next intersection. There, minor. So we're doing the measurement of angle X equals major arc minus minor arc divided by 2. So 160 minus 80 equals 80 divided by 2 gives us 40 degrees. All right. Now what if we're looking for one of the arcs this time, which you'll run into those problems. We're looking for one of the arcs. Again, you still set it up the same way. We still have the measurement of the angle is equal to major arc minus the minor arc divided by 2. Okay. Now, so as we plug things in, we have the angle. That's our 30. So we got 30 right there. Equals. We don't have our major arc. That's what we're looking for. So that's our x. Minus, we do have the minor arc. In this case, this is 70 right here. Over 2. So again, the whole point is to get x by itself. So let's start by getting rid of 2. Multiply both sides by 2. You get 60 equals x minus 70. And then we just add 70. Get 130. 130 equals x. So this major arc is 130. So let's try that. Just double check. So x equals 130 minus 70 divided by 2. 130 minus 70, that gives us 60, divided by 2, gives us 30. Good. Those should match. Perfect, y'all. Hopefully this helps, and catch you in the next one. Bye.